So our next panel will be focused on AI for business. Today's panel will be led by Francisco Solsona. So Paco Solsona is a Google engineer leading developers relations and accelerator for Spanish-speaking LATAM or SP LATAM, with 25 years of experience in technology, tech communities, and entrepreneurship. Redefining on-the-ground engineering for Google in SP LATAM for the past 6 years, Paco has focused on one of the strongest and cohesive networks of leaders, influencers, and partners in the region. And together they're helping developers and entrepreneurs thrive. Please welcome Paco Solsona.
Thank you so much. I'm super happy to be here. I studied computer science just around the corner at the School of Sciences here at UNAM. So I'm super happy to be here back at UNAM and happy to be with all of you at RIIAA. This is kind of like a dream come true. Last year we couldn't make it, but I'm really happy to be here and happy also to be closing the event with this amazing panel. I think that this is one of the key parts for general for education and technology to be useful for humanity, be able to use it in not only in education and research, but also bring that into businesses, into real life people. So I'm happy to introduce the panel. The way we are going to do it is there's going to be small presentations so that you know that each one of our panelists is doing amazing stuff in their own fields, companies, startups. So I'm going to start by introducing my good friend Julian Eisenslochs. I don't know how to pronounce the name. Sorry. He's a mathematician and machine learning researcher focusing on NLP for low resource languages, co-founded BotMaker in Argentina. That's one of our leading companies in the region, creating bot makers and very good friends. A learning conversational AI platform in Latin America. Previously, at Facebook, he developed knowledge graph competition solutions based on crowdsourcing data. He's the organizer of the Buenos Aires TensorFlow Meetup and Google Developer Expert, another of our programs. If you are interested in being part of our network and helping us, let me know. I'll be happy to introduce you to all of our programs. And, well, basically he's working with Google Assistant. So help me welcome Julian.
Gracias a todos por recibirme y por poder estar acá. Realmente, como dice Paco, es un evento, un sueño hecho realidad. Okay. There you go. Right, so I'm going to talk about text generation from the trenches. And what that means for me is how to do text generation in an industry setting where you want something that you can put in production and that doesn't make goofy suggestions, right? And so I've been working in the customer service automation and augmentation space for the last 4 years more or less. And it turns out that it requires lots of NLP tasks, many of which you might have studied. So the speech-out intent classification, that means how can I recognize the intent of the user just from a few sentences? It's also recognizing the entities in the sentence. And there's many more. There's clustering and summarization, maybe for analytics and insights. There's question answering, of course. And there's control text generation. That means after I understood the intent of the user, the entities, and I decided how to move the dialogue forward, I need to decide what I'm going to say, so what information I want to convey, and then how I'm going to say it. So actually materialize it into a piece of text. And I'm going to focus the talk specifically on this. Basically, there's maybe two main ways in which this can be done. So there's like the neural, more academic-minded way. There's also what most businesses are doing. And I'm going to talk about how we are approaching it and how we are trying to find a compromise between these two solutions. Also, these are the slides if you want to take a look later. So the neural approach. Traditional way, so might be a little old by now, so you can also use transformers, by the way. But traditional way to do neural generation would be to encode the text, maybe with some LSTM network or some other neural network, into a fixed length dense vector. And then we can use that in a reverse process to the decoder to auto-regressively generate one token at a time a response. And that is great in theory, but it has some problems if you can deploy that in production, sadly. For instance, this is a very interesting paper from people in Washington University about text degeneration. That means that because we are trying to select text that is very likely, sometimes it tends to repeat words, or it tends to do very simple things like saying, I don't know, or yeah, sure. So things that appear a lot in the text that is trained with. Another problem is that can be very unpredictable for specific use cases. There's the example of Microsoft Turbot. And even when the generated text is not racist or other things, it can also be inconsistent across terms. That means that it doesn't have a fixed personality or style. Maybe you will ask what it does for a living, and then what's its work, and it will say two different things. Another interesting problem that some people like Google and other places are trying to solve is that it lacks levers and controls to control that text. That means, how can I change the style, the type of dialect, etc. Those things are very hard to do when you're operating on this, let's call it thought vector. And another thing I wanted to point out applies to text generation, but also to other problems, is how do you do this beyond English as well? Because I work a lot in Spanish and Portuguese. And there's a few tricks that maybe we can share. One is well known, it's called BPE tokenization, binary encoding tokenization. This idea that instead of operating on words as units of knowledge, we can operate on parts of words, maybe prefixes and suffixes. And for languages that are very morphologically rich, such as Spanish, this is very useful because we learn embeddings and representations not for the whole word, but by these parts. And then we can compose these when some parts change and the other remain fixed. So that means we can learn better. This makes a very big difference for training models in Spanish. Also, in Spanish, do not, or other languages not English, do not trust off-the-shelf lists. Many basic tasks, maybe such as lemmatization and stop-word lists that work well in English, you have to double check, so always do your due diligence. Watch licenses, just another example that something that caused some suffering in my experience. There's one of the biggest Spanish data sets called Ancora. It has a GPL license, for example, so I have to watch it for commercial use cases. And finally, there's really no free lunch. There's really nice, fancy architectures that try to do zero-shot transfer across languages. That means I can train with only examples in English and hope that it works in Spanish, Portuguese. But that turns out to be, in my experience, like a nice curiosity, but not good enough for real use case. So there's no avoiding going and getting training data. So moving on to the approach that most companies use for text generation. Usually you end up relying on some sort of rule-based method. For instance, just templating. You can come up with some examples and replace the text according to the metadata of the message that you want to convey. And as you know, this might be full of special cases, not only the templates, but also if-elses and the number and genders of the words that make it hard to scale. Also, it can be monotonic because it's always saying the same thing in the same way. And also, it's hard to scale because of these issues. If you have multiple deployments, multiple bots or agents that you want to build. There's ways to help fix this, like coming up with different examples, but it takes time. Or writing down all of those special So we would like to find a way to get the best of both worlds. And in our experience, it turns out that this way comes from the feedback in the product. The fact that we are owning the full loop, so we have human agents that are also responding to customer queries. And that gives us lots of valuable information. For example, we can use that human-made text to generate lots and lots of candidates of text that would be said in the conversation in different contexts. And text that is natural and makes sense. We can use some clustering techniques, also heuristics, to remove maybe privately identifiable information and select some of the candidates with clustering that we know that would be used in our conversations. And after you have these candidates, we can fall back into these neural generation techniques that we had initially and only rank these examples that we like, this wide list of examples that we like, using the neural generation techniques. So we guarantee that we're not going to do goofy things, but we also have a very flexible pool of examples to use. And one last thing before wrapping up is that another thing that we're looking into, I'm researching at the moment actually, is this idea of prototype then edit methods. This means start with one of these prototypes, like the ones we selected here, and use a neural method, but not to generate from scratch, but finding how to edit, how to make changes in a sentence to apply for the specific metadata for the specific turn of conversation. This is also very promising because we can get the best of both worlds. That is all. Thanks a lot.